Okay, this next video is going to address learning outcomes C9, 10, and 11, looking at different types of energy, chemical reactions, and then metabolic reactions and what they mean and their importance to the body. Alright, let's first then talk about energy. What is energy? Well, it's the capacity to do work. And there are different types of energy. And those are listed down here. Chemical energy, which would be the energy that's contained in chemical bonds. The bonds between atoms, when they break, they release energy. That energy can be used to do work. Heat is a form of energy. Light, electrical energy, and then there's free energy. Please make sure you know these. In the body, the energy currency that the cells rely on is something called ATP. Adenosine triphosphate. That is the body's energy currency. Essentially, it is a type of what we call potential energy. And potential energy is energy that's stored within an object or stored within something that's not being used. And in the case of ATP, the energy is stored in the bonds. If we were to draw ATP, here's our adenosine, here's a phosphate, here's a phosphate, and here's a phosphate. The energy is stored between those phosphate bonds. And what we'll find is that 99% of the time, in certain situations there are exceptions, but 99% of the time the bond is going to be broken between the third and the second phosphate here, and that energy is going to be released, and that energy then facilitates various chemical reactions and processes within the cell. So ATP is very, very important. Kinetic energy, on the other hand, is the energy from an object that is actually being used to do work. So it's the energy from within an object that is being used, or that the energy is being used for something. For example, if you go skiing, you're at the top of a hill. You're going to use gravity to go down the hill. Okay, while you're sitting at the top of the hill, your body is full of potential energy. Once you start going down the hill, you're using that potential energy. It's becoming kinetic energy as you're going down the hill. If you were to strap some type of motor or something on your skis that were to spin as you're going down the hill, we could use that momentum down the hill to generate energy. In any case, please know the difference between kinetic and potential energies. So that's learning outcomes C9. Okay, learning outcomes C10, chemical reactions. Okay, chemical reactions are defined as the breaking or formation of chemical bonds. Breaking or formation of bonds. So in other words, we are joining atoms and other molecules together, or we are breaking atoms apart from each other from the molecular state into their individual atoms, or breaking down very large molecules into smaller molecules. All right, so a decomposition reaction is just like it sounds. We're breaking something down. So if we have molecule AB, we can break that molecule down to its component parts. For example, sodium chloride. We can decompose that into sodium and chloride. Synthesis reaction, on the other hand, is just the opposite. We're taking individual components and we're joining them together to make a new compound or new molecule. So, taking that sodium, combining it with a chloride, exchanging those the electrons, and we're going to get sodium chloride. Exchange reaction is a little different. That's where you're actually taking something like this and you're switching things around. So you're breaking down, let's say maybe you're going to make this and be left with this. Or maybe you're going to make this and be left with this. So you're just kind of switching things around. And these are very common as well. This is what happens a lot with ATP. ATP will actually transfer the phosphate from one molecule to another. And so we're left with, well, this is what happens in what we call cellular respiration. We take glucose and ATP, and what we end up with is we get a glucose with a phosphate on it, and we're left with what we call ADP, adenosine diphosphate, because we've lost that phosphate. So that's an exchange reaction. All right, learning outcome C11, metabolic reactions. I mentioned this briefly in another video. I mentioned the word metabolism. Metabolism is defined as the sum of all, or in other words, metabolism is defined as all the chemical reactions that are occurring in the body. What we'll find is that there are decomposition reactions occurring, there's synthesis reactions occurring, and there's exchange reactions occurring in the body all at the same time. And so that's what metabolism is. It's all these, regardless of if we're building something or breaking something down. Now we can define these metabolic reactions according to what specifically is happening. We have anabolism or anabolic reactions. Anabolic reactions are reactions where something is being created. We have catabolic reactions. This is where something is being broken down. For example, we can take a polysaccharide, a very long sugar chain, and break it down to its individual sugar molecules. That's a catabolic reaction. On the other hand, we can take individual glucose molecules, bond them together to make a long chain. That is an anabolic reaction. So we're building something from component parts. There's a third group of reactions called oxidation reduction reactions, and I don't want to really get into that because we get into that in Biology 106, but oxidation reduction reactions involve the transfer of electrons between molecules. This is different than the transfer of an electron from an atom to another atom. This is the transfer of electrons from molecules, from one molecule to another. And also what you'll find is we're actually going to see the transfer of protons as well. So they kind of happen together. We'll just leave that as that.